When I first began learning how to code, the concept of software design didn't hold much significance to me. I recall learning about the solid principles in one of my college classes, but at the time, it seemed like abstract concepts that I needed to memorize for an exam, with little practical relevance. At the time, if my code passed the tests, it was good enough. However, I forgot about whether my code passed one very critical test, the test of time. This would change during my first internship when I was introduced to a real-world code base. Initially, my sole focus was on meeting deadlines and passing tests as quickly as possible, without paying much attention to design principles. It wasn't long before I started encountering the consequences of my oversight. Modifying and extending pre-existing code, especially my own, became increasingly challenging and time-consuming. It was during this period of frustration that I began to appreciate the importance of good software design. If you're a computer science student or a junior developer who shares this mindset, you are likely to reach a similar conclusion sooner or later. Fortunately, in the early 2000s, renowned software engineer Robert C. Martin introduced the world to the solid design principles. A good understanding of the solid principles will help you write more maintainable, reusable, and decoupled code that is easier to test and less prone to bugs. In addition to that, it also makes your code more organized. So, let's get right into it. The single responsibility principle states that a class should have only one reason to change. In other words, a class should have only one job or responsibility. Let's look at the user class here. It does two things. It contains user data and also allows you to save it or load it from a file. Despite the class's small size, it still has two responsibilities. If we were to apply the single responsibility principle to it, we would create an additional class for user storage and move the user storage code there. Open-closed principle. Software entities should be open for extension, but closed for modification. Take the following example of some classes representing different shapes, each with a method that is for drawing the shape the class represents. Say we have a method that takes a container of different shapes and draws them. To do that, we would have a list of if statements that checks the type and calls the right draw method. This is bad code. There's always the possibility that someone could add a new shape but forget to update the if statement, which would result in a bug. In this example, we only have to update the code in one place. But in the real world, you deal with massive code bases, and if your code is not following the open-close principle, it could be very problematic. Here we have a possible solution that follows open-close. We create an interface shape, and then each of our shapes can then extend it and implement its own methods. This saves us the hassle of worrying about what type the shape is. And in draw all shapes, all we have to do is simply call draw. It is now highly unlikely that we would ever need to modify this method. Liskov Substitution. Objects of a superclass shall be able to be replaced with objects of a subclass without affecting the correctness of a program. This means that, given a class B that is a subclass of class A, we should be able to pass in an object of type B to any method that expects an object of type A, and the method should not give any weird behavior. Take the following example. We have the class bird with fly method and some child classes extending it, representing types of birds such as a pigeon or a penguin. When the penguin class extends bird and overrides the fly method, it will throw an unsupported operation exception because penguins can't fly. Now let's say you have a method that calls fly on every bird inside of a bird array. If you have a penguin inside that array, you will get an exception. This code is breaking the Liskov substitution principle because not every class of bird can safely substitute its superclass. Here's a challenge. How would you fix this so that fly doesn't crash, no matter what you have in there? Pause the video if you'd like to think about it. If you're a beginner, you might have made a guess like, let's add a Boolean parameter to bird that says whether it's capable of flying or not. That may solve it in this particular case, but that doesn't solve our Liskov substitution problem, as still not all children of bird can substitute bird safely. Another solution could be to create two classes, flying bird and flightless bird, that both extend the bird class, and one has the flying method and the other doesn't. You would have pigeon and other birds that can fly extend flying bird, and penguin extend flightless bird, and then you would change the type of the array in our method to flying bird. Now, this solution both solves the problem and follows Liskov substitution, but it is not the best solution. First, you are adding an entire level to an inheritance hierarchy for one very small purpose, being the ability to fly. Secondly, it might work in this case because flying bird and flightless bird are mutually exclusive. But what happens if you add a third class named swimming bird for birds with the ability to swim, and you wanted to create a duck that could both fly and swim? Now you have a problem because you can't extend two classes in most languages. Instead, the best solution is to create an interface for objects that can fly named Flyable, and implement it for each bird that can fly. Now instead of passing in an array of bird, you pass in an array of Flyable. This is also super neat because it doesn't even have to be used for birds. You can reuse it for other types of things that can fly, such as if you had a plane class. Interface segregation. The interface segregation principle states that no client should be forced to depend on an interface that it does not use. Or in other words, it's better to have several specific interfaces rather than one general purpose, all-encompassing interface. Let's look at the following code. We have a worker interface that works and eats. The human worker implements this interface just fine, but we also have a robot worker, which does not support the eating operation. Instead, our robot worker charges itself. What a novice might do would be to add a third method to the interface named charge. But all you would have done in this case would be to double the problem we previously had with two unsupported operations. This is when you have to split up your interfaces into more specific cases. Dependency inversion. Dependency inversion states high-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details, meaning concrete implementations, should depend on abstractions. In simpler terms, dependency inversion aims to ensure that in a system, rather than having high-level modules depending on the implementation details of lower-level modules, both high and low-level modules should depend on interfaces or abstract classes. This approach allows for more modularity in software, making it more maintainable, scalable, and flexible. Let's look at the following code. Here the switch class directly depends on the lightbulb class. This is problematic because if we introduce other types of devices, like a fan, the switch class would need changes for each device, violating the open-close principle and making the system rigid. Now let's look at the modified code. Here the high-level switch class doesn't directly depend on the low-level lightbulb class. Instead, both depend on the switchable interface. If we need to introduce more devices, we can easily do so by implementing the switchable interface without having to modify the switch class. This approach decouples the switch from the devices, making the design more modular and flexible. And with that comes the end of the video. I hope I did a decent job in improving your understanding of Solid. If I did, please leave a like and maybe subscribe. Have a great day.